Hello. Can you hear me? Five out of five. All right. Hot Wheels. Nice. Okay. Welcome to this live stream. Today we're gonna build cine horses here. Hi. I know we interacted a couple of years ago actually on Discord. Right. Okay. Today we're gonna build the version 1.0 of my pan tilt slider motion control rigs. And that's gonna look like this, hopefully. So, any of you familiar with the old design? It's quite different. This has like a little hood here now for all the electronics inside. If you've seen my last devlog, I changed the rail to this V-slot rail. We have this little box here for all the slider stuff. So it's all neat. This thing here is a cable chain. Yeah. That's what we're gonna build. Yeah. One thing is I've never built it completely before. So today will be the first time. I brought a lot of time. So it's now, yeah, 5 o'clock in Germany. Let's see how long this takes. Okay. Right, yeah. Okay, my setup here. Microphone is fine, I hope. I bought a new shotgun mic, fiddled around with compression, equalizer, and all this stuff. I hope it's better than last time. Last time I borrowed a headset from work, and it was I listened to the recording afterwards. The sound was complete garbage. So I hope this is better. And the other thing is I got quite a few angles now to play with. Got like one really wide. You can see the whole table and a little bit of tools. And one close up here. And later when we're gonna solder PCBs, I can bring it in even closer so you can see what I'm soldering, hopefully. But for now, let's keep in the wide. All right. Yeah, I thought let's start slow with doing inserts first. Oops. This thing here. I will just get my plans over here. Or maybe, yeah, you know what? This guy here. Good. Okay. I'll show you what I'm doing. I'm isolating the component I want to do right now. I'm working on a full like build guide as well. So you will get pictures from inside Fusion with all the build steps. And so you can hopefully recreate it. You'll get, of course, all the, 3D files, 3D print files. I have a full bill of material with, basically serial numbers where you can order it. Get all the PCBs. Yeah, as much information as I have. Okay. Let's maybe do it like this. Component priority. Good. So we will start with this little guy here. It's a short M3. Okay. Maybe we can already go to the close-up. Yeah, that's better. So for these heated inserts, you have to insert like a special tip, or it's recommended to do so. You can do it with the normal soldering iron tip, but that's gonna trash your tip pretty fast. And these kits are not that expensive; they're okay. So we need there we are. Hello. I can't read your name. Sorry, Moitchadul. I'm so sorry. Let's get okay. I know with black PLA it's a bit difficult, but can you see what I'm doing here? Maybe I give you a bit of a close-up here. So that's maybe a bit better. Still with the black stuff, I can turn up the lights a bit. Where are you? That's this one. And this one. That's nice and bright. So M3 short. There we are. Good. Get another short one here. Focus. Good. Yeah, okay. Got like my telephoto lens on here. So it's got a very, very small field of focus. But okay. Good. Next to it's here. It's a normal one and a normal one. Thinking about fixing the focus of this one. So jump around so much. Okay. Let's see. That looks good. Ha. Okay. It's not the best from assembly because you have to get in a kind of an angle, but yeah, well. Maybe through here. Ha. All right. That's good. Then we have it's more with M3. So done. Okay. Let me show you. Good. So those are done. This out. Let's do these 4. Because otherwise, oh, the M3 are done. These ones are M2. Yeah. So same as the ones here. That is M2. Yep. Okay. Then we switch to M2. Yeah. If I don't switch the camera, you can't see how I get burned. That's good. So, yeah, this is... I won't play music on the stream because I got claimed once, so feel free to bring your own music. Maybe even recommend something in the chat. So, it's hot. White shot. Bring in the white shot as well. Okay. Now we need no 2. 2. How do you like this? I got this tracking face cam. Follows me around. Is it distracting or is it good? Just thought maybe, yeah, I don't have to worry about, if I'm in frame or not. It's this light. It's this light. That's better. Okay. M2. Okay. There's a problem with this print. Let me show you. So, camera with the tracking. That's the Elgato Facecam Mark II. It's, yeah, if you dial the picture in, it's okay. So, for example, if I do like a full shot here, it's a bit soft, not as crisp, but the other ones are DSLRs, so it's a bad comparison. Not cheap for what it does. It costs like $130. But yeah, the face tracking is pretty nice, and overall, I compared it with like the Logitech 920, which is like a $50 webcam that's very popular on Amazon. But this one, didn't like it. Not a very good image. But this one is alright. If the light is okay, then yeah. And if you have it like this, like a small box in the corner down there, it's more than enough. Yeah, you see these here, they printed bad. I didn't catch that. So we're gonna try to get some inserts in anyway, but I will have to reprint them, or yeah. What has to happen here is there needs to be a bridge between these two packs because it is printing like this, and that's very hard to see, but these packs, they are floating in the air. So it has to start from nothing here. I didn't catch that. So yeah, that's the first thing. So version 1.01 already in the works. Let's open this up a bit with a screwdriver. Try to get it in there. So, okay. I'm only gonna do these two right now because the other ones, this one, that's not possible to reach. I just, yeah, noticed. Well, maybe this one here in the back could be. Let's see. Yeah, this little guy. So this one, let me switch again. It's one of my favorite tools. Hey. This is, you can buy this from like a wet supply shop, or yeah, on Amazon they have it as well, but it's basically a supply for a wet, and they use it to pull stuff out of dogs' ears. So it has this little grabber at the tip, and it's very good if you have like this small M2 insert, like this one here. Can just grab it and then put it somewhere where I can't get with my big fingers. No, it won't stay there. So stuff it in a bit. All right. So now it's in there. Back there. And now we're gonna try to reach it like an angle or so. Careful not to burn the top here. But okay, we got 3 of them in. The 4th one, it's so misshapen from the 3D print. Yeah, I will not bother. 2 would be enough already to hold the PCB. It's not like we're like driving through a mine with this thing. Good, M2. The next M2s are up here. Let's get all the focus going again. What am I switching something? Autofocus, stabilizer, right? Should focus. There you go. There you go. Okay. Yeah. We are doing. Can you see that? These small ones on the top here. They are also M2, and they will hold the the switch for the end stop of the slider. This one in, and get another one from the box. Okay, so those are in. And that's all we have to do for this part. Yeah. Okay. Put this aside. Okay, next one. for the noise. Can't even see what I'm doing. Just do the big one. Okay. Right. Okay. This one. This is the case of the focus unit. Close up. It's called Focus Pocus. Trouble focus maybe because a little bit too dark. Yeah, I could get it a bit brighter maybe. Let me see. I'm maxing out these lights here. So, no, I'm very... yeah, with the Elgato you can manually adjust your like brightness and all. Focus Pocus, yeah. Thought long and hard about this one. Do we have the old version here? Yeah, there we go. So, the old version of this case looks like this. And what the difference is, I made these letters with nail polish, you know, my nail polish technique. But we're not going to do this for this one. I have printed all these little tiny letters in white, and we're going to glue them in. I tried this before on like, where are you? There you are. On this back plate. And it works great. You have like a little 3D effect and so on, and it's, yeah, the smears around are from the nail polish below, because at first I tried it with nail polish, but then I printed these, and this looks way nicer. So that's what we're gonna do. All right, Focus Pocus. You have... Oh, okay. Let me open this here. Focus, focus. There you are. Deselect. Okay. Turn off this. Turn off the lid. So there aren't too many inserts here. Got this one, M2, the others as well, I think. And the other inserts are like the big ones down here for a 1/4 inch 20. So you can mount normal, like, yeah, film gear hardware. Yeah. Okay, so M2. Yeah, you can't see anything. Close up. Good. Oh, come on. Yeah, two. There we are. That's that. Now for these big holes down there. These are 1/20. It's almost a little bit bright right now. Okay. Yeah, I have to change the tip for this. Here. So that's like one ginormous one. A 40/20. Yeah, that is it. It's the same as the one for M6. Sound is better this time. Yeah, I'm glad. I did a lot to improve it. I don't know if I have posted this, but yeah, basically the time since the last live stream was 2 or 3 weeks ago. I installed like a professional. No, it's a basically it's a long metal pipe you use for professional lighting equipment on like live shows and so on. I installed this to my ceiling here, and I hung all my lights from the ceiling as well as the new microphone and the cameras. So yeah, no cables on the floor anymore, no light stands, no tripping, and the quality is consistent here. Yeah. And also I got this new camera and a microphone, and I tweaked my setup a lot. And yeah, I think it turned out great. I listened to some, test recordings, and I'm really glad with how it came out. And the new microphone is amazing. It's the Sennheiser MKE 600 or MKH 600. There's a 600 in there. And this is like a shotgun mic, which is 1 foot away from me about. Yeah. And this is great. That it sounds like a big condenser mic right in front of you. And it also gets a little bit of the noises on the table for more immersion, ASMR if you want to call it that. Yeah. You need more heat. It's a big insert. It's always focusing on my hand. The little rascal. So now I go in. So focus there. Good. No, it's too close. Cannot focus. Yeah, that's what it looks like. All the small ones in there. All shiny. Burnt my finger a little bit. No, it's still very hot. Okay. So that's done as well. Check my magic box. So that's all the stuff we have to assemble right now, at least the 3D prints. So this one has no inserts, so this can go aside. This one has them. Yep. Nope. This one has one. Yep. Nope. Yes. Yeah. Yeah, almost all. I did the bill of material, and in total, it's like 100 inserts or so. It's crazy. Stuff. Oh, we have. Yep. So I don't have to switch the, the adapter as much. Show you. So I know under here there are more of them. Yeah. Okay. Let's put those in. Here I'm not gonna not gonna do all 4 of them. 2 is enough, really. Just have to kind of jam them in there, and once they are hot, they will align themselves. I have optimized the printing now. One here in there. Yeah, I've optimized the printing now that nothing needs support except one part, the big back cover, because it has these ribs that go horizontally, and that's the worst you can do for 3D printing, but it looks cool. So I kept them, and you can get away with these organic supports and build the structure there. Bit of a pain to remove. Yeah, maybe I will change this, but not in this version. I am in my CAD model. I am now on iteration 303. This model has been going on for the last 5 years. So I want to close the lid on it. I want to have it done. Okay. I'm feeling that these inserts, optimal temperature for the threaded inserts, yeah, that's a bit of a debate. So the theory is you have to go above the glass transition temperature of your filament for PLA. PLA, I believe that's 90 degrees. But with 90 degrees, you're going nowhere with inserts. For smaller inserts like M3, M2, I can get away with 150 degrees. With these bigger ones like M5 or quarter 20 or M6, I'm going 250, 300. It's also a question of patience, and I don't have that. So if it's too slow, I bump it up 10 degrees at a time until it flows okay. but the ones we just did were at 305 degrees. Yeah, if you think about it, your hot end has 220, so 300 should be fine. Good. That's the quarter 20 here. It's the only quarter 20s we have. So we are swapping again. And now maybe let's do all the M2s. Okay. Yeah. If you're fast enough, you won't burn yourself because the tip is still hot, but not the adapter. So let's go down to like let's say 180. That's okay. Okay. So M2s are basically all the things that have PCBs. Where are you? This thing, for example. This is screen cap. This is this lid in here, which is like a lid on the bearings. And also you see these 3 holes here. That's where you plug everything in, like the focus unit. This one is to power the camera, and this one is to trigger the camera with a 2.5 millimeter wire. So these cameras, most of them have wire triggers. And I tested them. I have isolated the circuit with optocouplers, so there's no chance of blowing up your camera. And the way I have envisioned this is that you get in Gerbil, in the control software, you give like a spindle coolant on and off. It's in the G code. And with that, you can trigger the camera and trigger the focus. That's the plan here. So, get you back to this. Close up. Just have to search them. Stuff. That's M2 again. Good. See, this is 180 degrees. And it's going in like nothing. Very easy. Yeah, those are fine. And that's it for this one. Any other M2s? Can just new function I discovered in Fusion. And that is have everything visible. So, and now I can select by name. What I want is one as an example. M2X4. So, find And now I know all the M2s. So the two up here we know already, we have done. These are the three in the focus unit. They are done. And as you can see, there are 4 in the base here. Those we still have to do. So let's get the base. This is, I know, yeah, it's probably the longest print of all this stuff here. It's like this. I should probably, you know, split it up here and keep it together with the metal brackets. But yeah, not this version. I want to get done. Okay, there they are. All right. Oh, okay. Those M2s. And then the ones in here we already did. So M2 is done. Yeah. Okay. And we can switch the tip to M3. Yeah, let's maybe keep working on this part. It's the most inserts of all of them. So what's everybody doing this evening? So just watching me fiddle around here, or you're doing projects by yourself? Or yourself? So, 3. Fusion has to think about something. Okay. Slider. Good. Those are M3. Normal M3s. Again. Too impatient for 180 degree. Let's go 240. It's like there should be short inserts here, not full size. Yeah, screen. No. It's enough room in there. You can see the little cave below. Yeah, okay. Then let's go with the big ones. Insert in. See it like that. Ha. I need to go somewhere. We'll continue watching when I get back. And you're still streaming. Stay healthy, brother. I will. See you then. So yeah, goal today would be to get this thing moving, basically built completely and moving. And yeah, we have a bit of time for this, but yeah, let's see. That's at least the goal. I know a lot of my viewers are not from Germany, as I am. So I will try to stay on for longer so more people can catch the stream maybe later on. Because majority of my viewership is from the US, and yeah, it's a big time shift to there. All right, we have all these ones around there. They are for this lid to stay on. Good. Now we can do probably those here. Yeah. Let's see what kind they are. Normal M3. Now you're in focus. One more. So these inserts are for metal brackets, so they go to the left and right side of the big part of the slider, and they give the most stability. I used to have, like on the back of the 3D print here, like a big triangle shape which would hold it up, but it wasn't enough. And these metal brackets, they are, yeah, it's the best thing ever. So I don't have to worry about stability, not as much, but yeah, they give a lot of strength, and they are just for furniture. They're nothing special. Last one. So is anyone in chat like building also motion control stuff, or are you just here to see if I would swallow a screw? Oh, shiny in there. Good. More M3s. Probably around here somewhere. Yeah, there are the attachment points for the backlit, like this stuff here. I'm thinking about how I can show this, so you can see more than the back of my hand. These shots probably a bit wider than this. It's a bit more in focus. Okay. Colin makes. You've been there last time, I believe. Great to see you build. Thank you. Yeah, I really recommend doing a live build like this. I hesitated for a long time because I thought no one would show up, and then I would sit there like an idiot for 4 hours. But yeah, people actually come, and it's the best thing ever to talk to people with the same interest. So if you're hesitating, just do it. No, wait, just... no. I have the memory of an old man, but I believe we exchanged quite a few comments on my last video, right? You made the slider with like the 2-meter V-slot. So. Try. 3 meter, yeah, 3 meter. That's crazy. This build here will have 1 meter V-slot. CNC shop online, yeah, I believe I've seen them. Where were the white clothes? There, you want to see stuff. That was me. So, I have only like a small screen here to see the live feed. But is it like at all visible what I'm doing here? Because it's like very small M3 inserts I'm pushing in there. Can you see what I'm doing, or should I get closer? Fine, all right. I've set up to stream a build a couple of times, and I think people underestimate the amount of preparation you have to do. Much respect for what you're doing. Yeah, thank you. Wishes are good. Yeah, it's a lot. It's a lot. Even setting up OBS and having like a stable feed, and how do you get your video in your laptop and so on. It's a lot of work. You're right. Yeah. Okay, that's M3 here. These are through holes, and those are through holes as well. Yeah, but this is M5. Okay, we have these big ones here, but they are M5, so I will save them for later. I don't want to switch the insert all the time. Let's put them aside. Maybe continue with this bad boy. Focus. Thank you so much. So, I don't know, yeah. It's, yeah, I'm still figuring out like an efficient process. Because if I just grab a camera and film and start talking, I will ramble and I will say nothing. But if I plan everything and write scripts and make shot lists and yeah, then I take forever for videos. So I tried this year. I tried to counter this a bit with these devlogs, which are just me talking, and I try to cut it into something that makes sense, and also live streams, because I don't have to do anything for live streams after I streamed them. It's a good amount of preparation, but with the setup I have going on here, it's like maybe an hour setup or so before I can start streaming. I have to clean the space and turn everything on and check if everything works. But it's like an hour setup time, which is way better than before, where I had to go for like half a day just to set up the streaming. Don't become a robot. Your live streams and videos are great. Thank you. Yeah, this is the shot list thing. That's more like for me, because when I do like a more rambly video, like my first ones, I don't like the video afterwards. And yeah, this with script it's okay. I hate writing scripts, but I'm getting better at it. And with the last scripts I wrote, I was able to knock them out in like 2 hours or so. Just sit down, write everything down. I let my wife have a look at it, if I've written complete nonsense or not, and change the wordings here and there. And then I do the script. I have a teleprompter now to read off the script, but I don't think that's really necessary. The video I'm filming right now, I'm trying to do like a Blacktail Studio, if you know them. And it's a woodworking channel. He does like epoxy tables, and I'm sure you have seen him in your feed pop up. But he films a bunch of stuff, or his cameraman films a bunch of stuff, and then he does voiceover over it. And that's what I'm trying. And coincidentally, it's also a woodworking project. And I will do I just filming everything. I have headphones on and listen to music and just do my thing and let the cameras roll. And afterwards I figure out what I'm gonna say. And let's see if this is better workflow wise. But yeah, I don't wanna like pump out a video every day or so. I couldn't even keep this up. If I get one done like every 2 months or so, then I'm pretty happy. That's very productive for me. But in between, live stream here and there, if I wouldn't be streaming, I would do this stuff anyway. So why not stream it? I find my voice over so much harder. Yeah. Well, I haven't done it with the voiceover so far, so this will be the first video with voiceover. If it's like my first videos were kind of voiceover, but it's also writing a script. Then to that script, I go through every sentence and I write down what shot I have in mind, like the angle and subject and everything I want, and write it down in a shot list. Then I shoot everything, and with the videos where you don't see me talking, it's a voiceover. I'm reading the script into a microphone. But in all these cases, I have planned what I'm gonna shoot. Now I'm gonna do the voiceover afterwards, so I see what I have shot, and then we'll try to talk over it. But yeah, voiceover for me was hard because, and that's with everyone I've ever talked to. I hate hearing my voice over headphones or like recordings of my voice. Can't stand it. But it's everyone, so that's okay. Good. M3, we are through. With this one at least. Let's do this. So we are this here, and yeah, I have to check to not put in the inserts the wrong way around. Screen cap. So we are here. Are we? No, we're not. We are here actually. These ones. Normal M3s. I thought they were shorts. But okay. Yeah. We are screwing in from this side, so no. Here we go. So, do you write a script for your videos? You're doing voiceover, or is it just like talking to what you see? Are you using 3D printed bearing in your ring? No. But I thought about it. I'm using here. Wide. Here. These crappy bearings from Amazon. They are, the only good thing about them is that they are cheap. They are made of aluminium or aluminum, depending from where you're from. And they can get pretty big, like 30 centimeters big. That's okay, but they don't run completely smooth. And yeah, the holes are also not like completely concentric here. It's a mess. I have more expensive bearings, but they are for future robots. This one I just want to get done, so they're getting the crappy bearings. And that way they are cheaper. Talking as I do it, no script. Oh yeah, that's the the rodeo variant. So, but are you a native English speaker then, if you do it like that? Because I find it hard to keep talking English for a long period. I have to do it at work. If like people from other countries, and after a day of lazy Susan bearing, yeah, precisely. That's how you can get them on Amazon. That's what they call it. And yeah, lazy Susan is the thing in the middle of a table where you put food on, and then you can spin it, and it turns around so everyone can get to the food. Where was it? Yeah, talking in English. It's very energy consuming over long periods of time. Yeah. One huge downside with these lazy Susan bearings is the weight, because I'm building bigger robots, which you haven't seen now, but I have like a robot arm in the making with 1 meter of reach, and at 1 meter every gram counts on like the base motor, which has to lift the whole thing. That's why I want to switch for the pan tilt head to basically plastic bearings, but they are high quality. I don't know if they are PTFE or nylon or whatever, but they are basically made for chemical plants, and they can be suspended in corrosive stuff like acids or so on, and they are very durable. Like a small bearing with 60 or 70 millimeters costs $30. So I haven't gotten a big one yet. But these are the ones I want to use, because the bearing itself, because it's out of plastic, made of plastic, it weighs like 10 grams or so. Maybe now 30 grams, maybe tops. Yeah. just realized with all the talking, maybe I should have used short ones. Why are there no short ones in here? Screen cap. Find in browser. Oh man. They are short. Okay. Okay. What happened here is I pulled these models from the Rutex page where you can buy the inserts or buy them on Amazon. But the way they did the 3D model is the body inside is called M3 5.7 and so on. But the component which contains the body is M3 short. So all of these should have been short ones. Okay, that's a bit of a mess. Let me show you the mess. There is the mess cam. They are sticking out in the back. But this shouldn't be a problem. I have recessed them here so they would not rub against the bearing back. But I don't think this will be a problem. Should be fine. Wrong camera. Good. Okay. These are all M5, M3 are in. Here. Oh, these rings. These are like little adapter rings that hold the end stop switch for the rotational axis. And yeah, they also need M3, but I believe those are short ones. Isolate all. There we are. Yeah, M3, but which one? M3 short. Ha, got you. So, we are coming from the top. Short. Good. So, if you're still there, laser, and from your name, I guess you're doing content about laser. What's your opinion on the X-Tool X1? It's like a big 40-watt diode laser. Have you tested it or seen it? Good. That's M5. Expensive, right? Very expensive. But yeah, we are looking to buy a laser. And the X2 ones have very good reviews, and the S1 is a closed one. So that's what I really want, a closed laser. My cats want laser themselves. But have you, any experience with the quality of it or so? I believe we are through with M3 and M2. We can go on to M5. Yeah. Only have a 10-watt diode, but I have now 30 video made on it and how I updated it. Ah, okay. Yeah, that's what a lot of people do. They improve it as they go. What you want to cut or engrave. Yeah, I want to cut. My wife wants to engrave. She wants to do like crafting stuff like Christmas ornaments, or cutting paper or felt, or, crafting stuff. I want to cut wood and acrylic plates for structural purposes. If I have like a lid or something big and flat, which is bad to 3D print, I want to cut it out of acrylic and maybe make face plates and so on. So yeah, I really would need the power for cutting. But yeah. Thickness. 10 millimeters would be good, I think, for some thicker stuff. I have no experience with the strength of acrylic plates, but 10 mil would be good. I want to make robot parts out of it, M5. But like an enclosure, yeah, very important for me. Also like fume extract and basic safety features like a fire detector. So would be great if it already has them. We'd get a much better edge finish, especially on acrylic with a CO2. Yeah. Cannot cut clear acrylic. Yes. Yeah. That's a shame. That's true. But CO2 lasers, yeah. Big and heavy and even more expensive. That's the downside with them. But ideally a big CO2 laser. Yeah. 150 millimeter inline fan minimum. What's an inline fan? Like for the air assist or for ventilation or... So that's those done. Good. This one is now completely done. All the inserts. Do this. I think extract fan. Ah, okay, so fume extract. Yeah. And then, yeah, what to do with it. So run it through a filter or just, yeah, dump it outside. But that's bad in winter. Gets pretty cold here. Hey, yo, Mirando. Ah, my buddy. Known him since kindergarten. So you have nothing better to do than watch me this evening, right? Outside, yeah. Outside, yeah. That's then more of a summer activity then. Well, you know, like a normal laser job, in your experience, how long does it take? I guess it's not as long as 3D printing, but of course it depends on what you do. That's for sure. But in 3D printing, you can go for, you know, like a day straight on like a normal print. Is it the same with laser? Come on. Yeah. All right. It's the watching other people work is way better than do it yourself. Yeah, I hear you. Yeah. Work is fascinating. I could watch for hours. Yes, much quicker on laser, but never leave a laser unintended. That's right. That's why I'm asking about the duration, you know, how long I have to sit there. But I guess if you're just cutting something, it should be done quicker. But if you have like a grayscale image or so, I've seen they take forever to do. Okay, this guy is all done. And you know what? Let's do him next. Here. I believe they are all the same. You. Bodies. M5. Normal M5s. Normal M5. Just seen we've missed some M3s on. Oh. My webcam froze. Yeah. Okay. Is the stream still moving for you? Because my webcam is frozen. Laser, air resist pump, extract fan, aluminum, extractor, honeycomb, bad, good, laser glasses, strong magnets to hold work down. Oh, good tip. CO2 fire extinguisher, water spray bottle. Yep. Yeah, that sounds good. I just have to kill my webcam. I hope I don't have to restart the stream. Ah, okay. Good. Can you see me again? Stream isn't moving anymore. Okay, how about now? There's much less chance of fire. Can hear, but its image is frozen. Okay, is it better now? I restarted the webcam. It should be back now. Like, I hope so. Now it's working. All right, great. Yeah, that's the one thing with the Elgato. It froze on me a couple of times, which completely sucks during live streams. But yeah, with engraving, there's much less chance of fire, but it's still there. Yep. Yeah, you're giving some good tips there. Yeah. I wanted to get a CO2 extinguisher in here anyway. For like, yeah, 3D printers and so. I have good printers now, but yeah, change is never zero. And we built a house completely out of wood, so fire extinguisher is not a bad idea, I think. Okay. So this side done, the other side. Water spray bottle, yeah. It's the first line of defense there. So you mentioned you had like a 10 watt diode, right? How thick stuff can you cut? Six millimeter MDF. Okay. Yeah, I was wondering about MDF because everyone always just cuts like thin plywood to show some tests. But 6 millimeter MDF, that's okay, yeah. You know, in all these, if you look on the Xtool website, they claim like 18 millimeters of wood. I think that's a bit, yeah, you would have basically a bandsaw then. A number of passes, but not quick. Right, it's not quick. Yeah. Good. Those are done. I have some M3s that I've overlooked, but we'll deal with that later. More M5. Yeah. There we are. Not trust what they list. Yeah, I have not seen a good edge finish on thick wood. That's the next thing, yeah. The edge finish then, and I want to make mechanical parts, so precision is not completely uninteresting to me. Yeah. Stay there. Yeah, the other thing for like structural sound and precise parts would be a CNC. But that's a whole nother beast with all the dust and mess. And I would want to do it in here, and we're just in my attic here. There's like laundry all around me. Diode laser not really vaporize, it burns through. Yeah. Are there small scale water jets out there? We are still talking about my attic, but CO2 laser does vaporize. Yeah, CO2 sounds pretty good overall, but yeah. The plan is to get something for Christmas, so let's wait till Christmas. I can do some research until then. Small scale water jets. Yeah, let's get some water piping up here. Good. I believe I have these. There's one M5 in here. Here to fix the axle. I'll show you some bodies components. Yeah, there is this. Stay here. M5 short. Just now I see, how should I get in there? Oh man. Well, let me try something. We could do two things. Yeah, okay. I will try an M5 bolt on its own to see if it grabs. If not, we will reprint this on the Mark IV. It will be done in like half an hour. Okay. What's the screw here? Components, all bodies. The screw is 5 by 20. So, because nothing is labeled in here, I have to measure them. Let's see. First try. And 5 by 20. And now let's check if this fits. It sticks. It fits, but it doesn't stick. Also, the diode laser beam is not round, but a rectangle. So it has a different curve on each axis, which can affect fitting parts together. This happens more with the bigger lasers, so check beam size. Oh, I have not heard this, that they are a rectangle. Yeah, all right. That's a good tip, thank you. So CO2 is sounding better and better. 40 watt laser does not mean you have 4 times the ability of a 10 watt. Yeah, that's also true. So what we are going to do now, yep, the screen. I will make this a through hole here, so we can just get the insert from the other side. Yeah, yeah. Let's do it like that. Like this. And blip. Bam. Easy. Let's print this. Yep. Gonna get this a CO2 laser, but they have small bed size. Yeah. Yeah. And for CO2 lasers, I've heard they are bad to ship. So if you get like these, what they call K40 or so from China, you're buying a project and not a laser. And what I want is a tool I can plug in and use right away. You know, I don't want to fiddle around and upgrade. I just want to use it. And to get that, I have seen high prices. Very expensive to get a good CO2. Yeah, you need to chill the water that cools the tube. Yeah, you need the big water chiller. Yeah. K40 crap, that's what I heard. Yep. Let me just switch on my printer 1 second. So in the bed, I like to use acetone. You can show this here. Acetone. I got this from the Fuchsia printer manual. They really say that in the manual acetone is good to clean the bed because it makes the what's it called, PEI stick again. So 60-watt red and black laser, also Omtech. Yep, nice ones. Rudio as controls for. Okay, thank you. I will look into that. Yeah, the other ones I have seen are like Glowforge, but they require like your cloud and internet connection and everything, and it's just bad concept. Yeah. No to Glowforge, yep. Just awful what these companies do to like bind you to their product. It's totally crap move. Okay. Yeah, this is my printer profile. I have printed everything with, like, everything you see here. It's the structural profile, which is the same as the quality profile from the Mark III. And all I did was switch to 3 walls instead of the standard 2. And this gives me all the stability I need. So let's slice this. 30 minutes. That sounds good. Upload and print. Perfect. Come here. Okay. Yeah. So we have to wait for this. The last M5. We have some M3s. Size nozzle. The standard 0.4. It's all pretty standard there. Really, even the PLA I just buy. That's a brand called Everyone, like everyone without the V. It's a Chinese brand, and I have been using them for years and have never had a problem with them. They have a nice finish, good stability, and if you just use the Prusa, a generic PLA preset, and that's all. Just no problem. I used to, you know, fiddle around with speeds and flow rates and all this stuff. Wasted a bunch of time, got me nowhere except wasting filament and going crazy over this printer. And now I just print with standard settings everywhere. Just one more wall, that's all. And it prints perfect. I don't know, that's like 99% of all my prints succeed. And if they don't succeed, it's because I didn't wipe with acetone or I made a crappy design, which, yeah, can't be printed very well. Go so much faster. Not much, yeah, especially the stuff you're making. I will not go back to 04. All right, okay. Yeah, I could. I have the other one, the Mark III as well. Maybe I could get a 06 for the Mark III because it's quite a bit slower than the Mark IV. And that way the Mark III could handle the rougher stuff. Yeah. Yeah, maybe I will look into that. 06 nozzle, yeah. So I've been thinking, I've been now online for, what's this, hour 50. I will do these more inserts here, and then I will take a break. I will eat something, drink something, and then come back in like maybe 10, 15. It won't be rough, right? Yeah, I will try it. Yeah, will be back in like 10, 15 minutes. Just take a short break. Take off these headphones because they're really warm and sweaty. No, don't burn my house down. Okay. So 3. But yeah, after these inserts, I will take a short break. You can take a short break too. Good. Good. Those. Too much detail about the headphones. Yeah. These are what I call biodynamics. I don't know the model name. They have always stupid names, but they are wireless biodynamics, and I really like biodynamics for headphones. I have the studio headphones wired from them, and they are great. They're really good for mixing my audio. It doesn't mean to blow your kids' fat fingers. Thank you for that. No, no, appreciate it. But yeah, they sound good, and they even have noise cancelling, which is okay. It's not as good as like JBL or so, but it does the trick for most stuff. And listening to music is very good. I haven't tried them for mixing or so, because if you get like hi-fi headphones or hi-fi speakers, it's awful for your mix. You will get because all this hi-fi stuff is like has a fat bass and sharp highs to get the sensation of loudness. And if you have properly mixed music and you play it over these speakers, it will sound good because it boosts your detail and everything. But if you want to mix it on there, you will mix it all wrong. You can always contact me to talk lasers. I'm GMT+1. What am I? This is your UK time zone, right? +1. Yeah. Because I think I am GMT +2. GMT. Oh, come on. UK, Ireland, Portugal. Yeah. Ah, okay, UK based, right? Yeah, we should talk sometimes. I will contact you before I make the decision. UK +1. UK +1. Ah, okay, yeah, it's close enough. Not Australia. Yeah, as you might have heard, I'm German. So that's the time zone. Oh, yeah. So. Come on in. Good. Okay. That's all the M3's done. The missing M5 is in the printer. Nice. Forgot about those two. Okay. Yeah. Okay. Let's get those two. This is the mount for the cable chain to the base plate of the gantry. So M5. Come on. Good. Okay. So, yep. Okay. Now it's 1852. Let's say 10 past. Yeah. What do the inserts? What do the insert tip for the hot iron just push out? Just push on? Not quite sure what you mean, but these inserts, that's called, they they don't stick out at the end, if that's what you mean. See, you can just, they are shorter than this, and that's the good thing in comparison to normal solder tips, because they will stick out at the end, and then you get molten plastic on them, and then they suck. But with this, you have like this shoulder around on which you can just push it. Yeah. Here. Sorry. Okay, no. This is a two-part thing. There is like with these Weller soldering irons, you have let me something here. This part here is like a replacement tip for your soldering iron, just like a normal tip here, and it's also hollow inside. So this thing here whoop, sits in here like this, and when you unscrew it, you up. These are threaded. So what I'm doing here is just grabbing and twisting to unscrew them, because I value my fingers. I do it with pliers, then they come up, and hopefully you can see they are threaded inside. Yeah. Hope that answers that. Right. Okay. There we are. Okay. So 1854 now. I will be back, let's say 10 past 7. So in 16 minutes. Yeah, right. Yeah. I will be back in 16 minutes. You will get my nice shiny new break screen. And I will see you at 10 past. Oh, all right, we're back. Okay. Got myself some tea. Can stay awake for longer. All right. Everybody back. Let's see. Okay. The last thing we did was get these two heated inserts in. What is this one? It's not these. Welcome back. All right, I got some. Okay. Okay. All right. Good. So we could start with the PCBs. Yep. Let's get the PCBs. So inserts are done. Can you hear anything from outside? Because I opened the window up and there are dogs barking outside. So, PCBs. Yeah. Again, can't hear the dogs. That's good. JLC PCB. Let's stick it together. This time just 3 PCBs. I got rid of the slider base PCB. The one that's in the spinny thing at the bottom. Yeah. Let's start with an easy one. Haven't thought of stuff in a while. Okay. Let's see if this has... Yeah. That's okay. So we have to remove the soldering tip again. The heat insert tip. Get a soldering tip. And not burn ourselves. But these are still pretty warm. Huh? No. Okay. So let me put these away. Good. Scissors. No, you can tear them. Tear them. And there they are. I get you closer. Yeah. That's fine. So I always get 5 of these because that's like the minimum quantity you can get. And Let's just say they're dirt cheap. They're pretty fast, and I never had problems with the quality. So there you go. That's an easy one. It's just 2 layers, no internal layers, and all through-hole components. I tried to keep 2 through-hole components on all my PCBs. But let's get the plans. Up. Electronics. We have camera-based PCB. There you are. Okay. Yeah. That's yeah. Once I'm done with the design and all the like production files, you will get a soldering plan basically. So all the components numbered with a reference to the part. But in here we just need some angled pin headers. Angled pin. Wide. So okay, that's as tight as it goes. Okay, some of those. So, and put it like, okay, yeah, it's mirrored. But we need 4-pin and a 3-pin. Three, 4. Okay. Yeah. I will get my solder wire. That's this little guy. That's an awful sound. So that's pretty sharp. Oh. Yeah. Yeah, okay. It's the best I can do with this lens, but I think it's too close. That's a massive 70 to 400, 70 to 300, I believe. Yeah, it's not very good in close distance. So Good. It's really not sharp, the image. I might switch lenses. Okay, let's do this. You get the other camera while. Okay. Good. Let's see how tight we can get. Okay. Not as tight as the other one, but at least it's sharp. That's okay. Okay. I will pull it in a bit. It's better for my back. Good. Okay. Good. Let's get the other one in as well. Ah. Hallo aus Brasilien. Currently working similar projects. Smokery for timelessly work is an inspiration. Thank you. Thank you very much. Looking forward to seeing your results. Auto agree. Der Weg ist das Ziel. For sure. Yeah. Der Weg is currently sitting at CAD iteration number 303. So, yeah. Yeah. Okay. So, you got a pan, tilt, slide, and zoom. Then or focus. Pan, tilt, slide, focus, probably, right? Good. This side is done. This big blue guy. Okay, let's look at the. Go on. Let's see. Yeah, the good thing in Fusion is that if you do the PCB in Fusion, you get a 3D model, which is very helpful for designing enclosures and so on. Just have to remember where I put these. It's in the PCB box. Where is it? I could say too much stuff. Yep. Yeah. Okay, so orientation is up. Yeah, I'm soldering and you can't see anything. Closer. All right. Okay. So, yeah, I should have put these two together, but they're right. So now we're doing those two here. One is already cut. The other one I just have to snip off. What do we have? 2x4. Man. Okay, this one has a crooked pin. You can rescue it. Okay. Yeah. Okay. Last one. Okay, that's this one done. Good. Oh, all right. Chair. Okay. Next PCB. Let's do the second biggest one. Yeah, with all these PCBs, you see, it's like, that's the one we just did, like this here. And this is the other one. They are the same size. The reason is you can buy these prototyping boards on Amazon and they have this form factor. So at least the whole pattern will be the same as the ones from common prototyping PCBs. So in case you want to build this yourself, you don't have to buy the PCB from China or so. Just get the schematics and a prototyping PCB and solder it in with a bunch of wires. That's what I did for the first few versions, and it works just fine. Good. Slider. That's a very big component there. Yeah. So do we have yeah. Okay. Good. That one is a bit smashed. Okay. I have to replace that tip at some time. But yeah, that's like still the first tip. Already not looking so good anymore. Okay. That's the big boy done. the capacitor. That's this. Let's switch to the other PCB. I'll take you with me. There we are. We can close this. Slider step around PCB. Okay, so we got the big one. Now we do the small upright one. Close. Maybe not, because this will be sticking out and it will make it hard to, yeah, push the other ones in. Let's do this, and yeah, the angled 4-pin. Better choice. Good. That's good. Okay. These are upright. Yeah. Okay. Now we can do the uprights. The upright ones. This one here. Okay. So we'll do it. It's 1 over. Good. Okay. So we need another terminal here. There are birds outside the window, and my cats are very interested. Good. So this capacitor up here is optional. I will only put it in if I get problems with the end stop. Yeah, let's put this one in. This here is to stabilize the power supply. We have a 12-volt supply. 1000 is a bit much. It's 470. So. And minus, yeah. Give them a little bend. Yeah, wrong way. Okay. Good. Now we just snip them off. Too flush. Okay. And that's this PCB. Easy peasy. Next one. Now, the next one, that's the big one. Bam. So quite a lot of components. Yeah, not a lot of components. This here. So okay, let's clamp this in. Yeah, I wish I had my fume extractor on, but it's too loud. Okay, there's all of them. Big parallel connector. This goes through the ribbon cable, going through the cable chain, through the end part of the slider. So this is a 6-pin we need. That flew somewhere. Ah, cats are picking it up. No, they're afraid of it. Okay. I have to think of something to get you in closer next time, because that's the best I can do right now. Oh, yeah, okay. So about an hour ago, I had to reprint a thing that had a bad design choice in it. We fixed it, and the print is done. So after the PCB, we can get the print and get the insert in there. Come on. Sorta. Oh, it's okay. Not pretty, but it will work. So, and this one here. Good. Okay. Yeah. Okay. That's the USB where we're gonna plug in the ESP-Duino. It's an ESP32 based development board with an the same form factor as an Arduino Uno. So all the shields and so on will fit. Okay. Okay, it's not coming off. There we go. I think I will change my setup because no one can see really anything what I'm doing here. I will try to get it down here. So That's a bit better. Okay, and I will try to hold it down like so. Then people should be able to see, right? That's looking good. Maybe a bit bright, but okay. And now you can see my horrible solder job. Good. Now this guy here. Okay. Yeah, it'll hold. We could do all the small stuff here. I think, yeah, I won't go with sockets on this one. I don't have 2x2 sockets. I always cut them to size and it's a mess. I would just solder in the optocouplers. And if one blows up, I have to replace it. That's just how it is. Good. That goes in there. Yeah, because we already put in bigger components, I can't just turn it around and expect it to hold, so I have to bend the pins. But that's okay. Another one. Bend them a bit. Okay. So that's the optocouplers. They they are there to switch the focus and trigger of the attached camera. And the reason why you don't just put using GPIO from your microcontroller or anything else is you want to, if you value your camera, you want to galvanically separate them. What this means is if on the primary side there's a high voltage spike or you accidentally put like the motor supply on there, the optocoupler will just burn inside its little infrared LED and that's it. If you have a switch, a MOSFET or a transistor, it might get a voltage spike through into your camera. And that's very bad. Because all the camera expects is really just a switch that switches it to ground. So you could do this with a simple push button. But with an optocoupler, you can use a GPIO pin to switch the thing. Resist. Okay. 2 of these. Go here, go here. Yeah, inside these optocouplers here, there's a little infrared LED, and like every LED, you need to use, excuse me, you need to use a resistor in front to protect it. Now you could think, why not just use the proper voltage? Why do I need a resistor? But an LED is not a linear component. This means during its operation, with changing heat and changing voltage and so on, it will draw more current, and this will create a runaway scenario. So basically, it gets a bit more voltage, then it pulls more current, more voltage, more current, and it blows itself out. And if you put in a resistor in front, the more current flows through the LED, the more current flows through the resistor, and it balances it out. It picks up the extra. I know this because last year I've built Christmas decorations with about 10 or 12 LEDs in there. And I thought if I regulate the voltage just right, I don't need these resistors. And like 10 seconds after I switched it on, all of them were blown out. All of the LEDs gone. Even though all the voltages were perfectly correct. So it's not about the voltage. Yeah, so we might have a few new people in chat here. Hello, welcome. Take a seat. We are building my motion control camera robot. And this is the first assembly of version 1.0. And you are here live to see success or disaster. The last 3 hours we have been putting heat inserts in all the 3D printed parts, and now we are soldering the PCBs. And after the PCBs are done, I think we can start with mechanical assembly, because after that there's only wiring, and I would like to do wiring when the mechanics are assembled, so I get the correct wire lengths. Yep, that would be good. So snip, snip, and snip, snip. Good. Looking good. So, what else is there? There we are. Okay, J1. That's like a little resistor I will put here for, I think it's in case the, not a resistor, capacitor, in case the end stop is like jumping. Or has, because the end stop for the slider unit is, it's a mechanical end stop, so a micro switch, and you have to debounce them, especially if you have long cables, and you do this. No, not debouncing. You basically you have to get rid of the noise on the cable. That's a debouncing you would do in a controller. But yeah, I put this in here as a precaution. I don't know if I will need it. Let's see. So these here, they are a bit special because they are for the voltage converters. We have two voltage converters, one for the ESP32 and the other one is powering the camera. So 2x4 Pin. And I bet you want to see this. Maybe even like so. So one of those. Good. Nope, that's not the mouse. There we go. We'll just clean them up a bit. All right. Let's see. If I put this here. So. So can you hear a lot of background noise from the window, or is it fine? Well, just trucks going by. Okay. So, and this one is missing. Let's get this one. And no, bend it a bit more. Have to get out of the way from the screw, but also the lid, because these capacitors are usually pretty tall. If you bend them down like this, come on, here, it's a bit easier. Okay. Let's solder them on. Could flow a bit better. Okay. Okay. And that's that. So if you align it like this, and wouldn't know the difference. Exactly the same. Good. Okay, PCBs are done. Let's clean up a bit here. Garbage. Okay. So, I will get now the part we just printed because it needs a heat insert. Good. M5 heat insert. Bin zuvor in Englisch zu schreiben. That's all right. Die alte Version schon mal nachgebaut. Alright, nice. Okay. What did you like and dislike about the version? Because I changed almost everything. I believe it's too small. But that's awesome. You, yeah, took the time and built it. Oh, yeah, right. I have to check the, the size of the insert hole. Need M5. Should be 6. What did I do? 5.2. Okay. I'm not gonna print it another time. I have to drill it. Too small. It should be 6.4, so 6.6. Let's show you. Yeah, mistake in here. And slider component. Here. This hole is too small for this insert. It is 5.2, should be 6.6. So that's 0.6, so 20.3 offset minus 0.3. No, that's not doing it. That's 5.8. 1.4. Bin. .6. Now it's correct, but okay. Yeah. The company You can't see anything. Close. Here we are. The company Rutex that makes these threaded inserts and also the threaded insert kit for the soldering iron. They also make these set of drills, and they're not special drills, they're normal drills, but they have the very specific sizes for the heat inserts. So if you're like me and you mess up the diameter of your print or of the hole, or there are tolerances in printing and you just want to clean it up, these will give you precisely the diameter you need. So we want M5. There's this guy here. Okay. Give the white shot again. Okay. Easy does it. Okay, good. Now it should. Okay. Back. You go back. Close, not this close. Like this. M5, no, short M5. Short M5. You see, that's the hole we drilled. Oops, come in. It's now exactly holding this. There you are. And now I can push it in. Good. So this is in now. Yeah, it's not too bad screw-wise. Don't know if you can see this, but there's a little bit of black stuff on the thread now. So maybe if I thread it from this side first, it will cut it loose. Okay. Good. Now I hope we're done with the threads. Don't forget to drink something. It's important. Okay, yeah. Now, could start with mechanical assembly. Yeah. Okay. Yep. All right. I'm not far enough with the assembly guide that I could use it here, so I will just use the 3D model. Component. Good. So, yeah, I will start here. Wide. Let's make wide not so wide. And close not so close. That's okay. That's the where are we close? Good. It's the PCB we just sorted, and now we can screw it all together with tiny M2 by 6 screws. Didn't know the drills yet, ordered them directly. Nice. I need to make Rutex a sponsor here. Because like 90% of the inserts I buy go to the trash. Not because they're bad, but they're used in prototypes. And yeah, then I make the next iteration. You can't reuse them, so they're going to the trash. 2x6. I'll let you in. This looks like a 2x6. No. M2 by 4. Even tinier. So that's M2 by 6. That's M2 by 6. Okay. 4 of these. Good. They don't seem to fit. These two. Ah, okay. It's just this one. Is this? No, M2 by 6. I think I have to change this one to M2 by 4. Ah. Oh man, okay. Mistake in the model. Don't know if you can see this clearly, but this intersection here, it's like, this means the heated insert was pushed into a solid wall. There's not enough hole for the insert. All right. Yeah, okay. I have to fix this in the model. But for now, let's use a smaller screw. Yeah. Can't see anything from there. So, this is fine. Maybe I will just, yeah, leave it at 2 screws. That's okay. Wonder if we can still get the motor in though. Let's find out. Go back. So, generic stepper motors here, nothing special. I pulled this out of, I believe, my ANET A8, my very first 3D printer. Screws are there. Two. Yeah, ANET A8, also known as my first fire. Not my fire though, but a lot of people's ANET A8 caught on fire, caused a lot of damage. But they were dirt cheap, like 120 bucks. But the steppers were fine. No, I cannot. I have to get out the PCB first. Is this one a bigger one? Because they are different 42 to 42 millimeters. I need a 17. 37.3, the one in the model, and that's a 39 millimeter. Okay, so we can't use this one. So we use this one. Okay. And this one fits. Screws. But these motors, it's M3. And that's M3 by 10 countersunk flathead. A little bit more context here. All right. So So and 3x10. First try. Okay. Let's see if it's still full. Yeah, sure. Yeah. Okay. So the model's still good. Now I can the PCB back in. It's all fine. Good. Now up here is where the end stop goes. Let's see. Yes. Orientation is this down. Yes. You can hear this, I believe. Okay, that's M2 again. M2 by 10. Screwdriver. Come on. Okay. Now we're in. Cables. Yeah, okay. Okay. And this one goes into here. First cable in already. Only 4 hours into the build. Okay. We could do, yeah, let's put the wheel on. This is, yeah, a 20 tooth. Normally it's the small ones. I have. This is the small one, 16 tooth. It's a bit bigger, 20 tooth. Also has the wrong bore, but I will use 20 tooth here to make it fit better to the extrusion. So the belt can fit easier through the extrusion. If you look here, if you look from the other side, you can see through here. So that this is all a bit relaxed there, and it will not rub against the extrusion. So let's line this up. It's the flip one there. Yeah, there we are. Good. So, and still a motor cable. We can connect the motor here. So, motor cables. And normally on the PCBs, you have pitch size of 2.54 millimeters. So that is 0.1 inch. And the other side here, which goes into the motor, has 0.2 millimeters, 2 millimeters pitch. Yeah, the other 2.54. So that's the one thing. And the other thing, you have to see here. Focus. You see the black wire crossing here. The pins on the motor are not consecutively numbered. They don't go 1, 2, 3, 4. They go 1, 2, 4, 3 or so. So 2 of them are twisted. And if you're like me and don't read the datasheet correctly, you have to troubleshoot for a month or so until you find out. So careful with that pinning. But if you buy these pre-made cables like this one, the pins are already twisted. So you go on here. Good. Just squish it in like this. Ha. Excellent. Good. Yeah. Now we should do the lid. But I have not prepared any of these. Let's do mechanicals first. So no lid. this here is done so far, we can put it on the slider. Yeah, let's do that. On the rail, I mean, we can put it on the rail. Okay. White. So that's the rail we're gonna use. It's a 1 meter V-slot rail. And cable support. So there is close up again. I've made these feet. They have just holes to the side. They go on like so. And they are mounted with T-nuts from the left and the right. So pretty standard, pretty easy. And 5 screws. So what do we need here? This one 5 by 10. Yep. Okay. They come in a bit. So here you have to make sure that the T-nuts are right orientation. Then line the feet up. Everything is well, you can tighten them. And as you tighten them, kind of look into the channel from the side to see if they twist all the way to get the most grip. Can help them a bit. Yeah. Both sides. Okay, so they are on. Same thing on the other side. Didn't grab. Come on. There we go. Sometimes you have to help them a bit. Good. Okay. It's on. Same as the other one. Now we can add this thing. Which screws? 5 by 16. For this to work, you need to have the end holes of your V-slot threaded. You can buy them threaded or thread them yourself. It's not so difficult. So 18. 16. Yeah. Did I mess up? Of course I did. The motor now is in the way. I have to undo the end stop and the motor. Yeah. I also have to undo the PCB apparently. Yeah. Oh, man. I really have to line this out in the assembly instructions. Else it's gonna be a pain to assemble. Okay. Put that in here. Now I can put everything back in. Okay. Now this one back. This clicky thing below, right? Yeah, clicky thing below. Okay, all there. And now we can install the cable chain. There it is. I already put the cables inside. And when you do this, put this in the menu, but do yourself a favor and split the ribbon cable in two, and it's the right width of the cable chain, and you can just push it through. This one here. Come on. And this one here. And 3x8 flathead. To fiddle them in here. will not fit. Okay, try this differently. Sorry, you can't see this really, but do it this way. Now, oh my God, who designed this? Okay. Those were the two screws to hold the, yes, in here to hold the cable chain. All right. Now for the cable chain itself, I have made this support bracket. Oh, music stopped. Good. All right. This support bracket, you have to thread it over the cable chain, like like so. So now it's over there, and then we fasten it the same way as the table feet. So that's the back side now, and we need 2 times 5 by 10. No, not by 10. What did we use here? That's not long enough. We need 5 by 12. Those. Oh no. These are the super flat ones. This one. 16. It's too long. Then I don't have to. Hmm. 16. Then let's use 14. I have to change this as well. Okay. Okay. They are in. We will have to adjust them later again when we know how far the gantry travels. But that's how we're looking right now. So, cable chain already doing its work. It's stiff maybe, but it will come around. Okay. Then let's do the gantry. Gantry itself, I have already pre-assembled. But yeah, if you buy this thing, it will come with instructions. Yeah. I will remove the table feed for this once. Okay. For all new people in chat, we are building a motion control robot, which will pan, tilt, slide, so dolly basically, and focus the camera. If you have any questions, feel free to ask. That's why we're here. Good. So this is going. I forgot the thing. Oh man. Just back off. Need to mount for the also yeah, basically everything has to be mounted already. So this and this thing. But I can push this in and can I screw it down? No. You do it like this. Make some room here. Yeah, okay. Here. Camera base. Here. Okay. Good. That's what I need. These two holes here. So that's from here. And then, oh, so other way around. Yeah. It's like this and that. Okay. For this, I have bought special low profile screws. Close here. These are very, very flat and they will not rub. Will not rub against the rail. This here. I have to count the holes in the 3D to see if I assemble this right, because this matters a lot. Okay, that's on there. Like that, right. And now I have to mount. Yeah. Oh no! There are inserts missing. Okay. Let's do it quickly. Those are empty. Should be hot enough. Good. We can screw those in. Yeah, there are more inserts. This one needs M5. Short ones. Okay, now we're gonna screw this one in. Yeah. It's here and slide this over. Just thinking about how I will get this on there, because I'm pretty sure the chain is too short. Yeah. means I have to loosen the other screws again. Yeah, okay. Hey. Oh, it's on. Gonna tip over any second. Fucking knew it. Put the other end in a vise so it doesn't tip over anymore. Okay. This is in. Now we have to put the other feet back on. Like those three. Okay. So feet are back on. So much work just to get here. Okay, but now, behold, of the way. Pretty nice, right? So now we can move this more to the right to make it more stable. That's okay. That's so much work. And now we can put the end piece on. The right side again. The one we reprinted. Good. Close the dirty side on. Five by 16. It's like those, right? Yeah. 18. Yeah, there are 4 screws in the model, but I think 2 will be enough. Okay, put the idler on then. Nah, it's the old one. We had to reprint it because there was an assembly issue. Couldn't reach the insert. But this is the old one. I did not figure out. There's the new one. There's the insert here. Okay, so long screw, and it says 23, so yeah, 20 will be enough. It's not holding anything. Five, even at 18. 20. Good. I don't know if I can show you this. No, but on the screw, go. You have the screw, then a washer, then the idler, and then another washer. Okay, then you can screw it on. Can you hear that? Maybe barely, but it's on. And now we could do the belt. Oh yeah, let's do the belt. All right, that is the belt. This is too wide for me to show it any more closely, but basically the belt moves through the V-slot extrusion, so inside of it. And that's why it's a little bit fiddly. You push through. At least you can see me shoving it. Let's do the long wire. Yeah, no. Okay. Let's do the piece of wire. Okay. The other side. Yeah. You see by the tape, I already used it to, I think, to pull through the cable through the cable chain, but I ended up not needing it. So 1 meter of this. Like that. And now push it through. Somewhere over there. Yeah, there we are. Now we loop it over here. And then we bend it. To a hook. And now we can just pull it through. Hopefully. Okay. Ah. Well, okay. Okay. Still tracking? Yeah, it is tracking. Good. Okay. So through. Is it twisted? Hope not. Don't know if it is twisted now inside. Kind of feels like it. Should be okay. Okay. So now this can come together in the middle. I have and another one. Uh, 10. Yep. Good. Now I bring you in a bit. So now you feed the belt through here. Put it down. It's holding into these ribs here. And now this will clamp it down. Good. Okay. So if I pull here now. Oh man, I didn't put it through the hole. Okay, try again. It. Good. So sound a bit. Okay. Now we have to get this through here. And I think I will clamp it down and then just cut it off. Should have enough tension. Now we pull on this. So on all the wheels and everything. Okay, pull. Then I clamp it down. Them together, not one after the other. Okay, now that's pretty well tensioned. Bit of excess here. That sounds good. Ah yeah, and also, oh, my music died, but yeah, the end switch will now work. See here. Here. Table too short. If I go here, you will hear a click. Good. But I think I will relieve a little bit of tension. Yeah, it's probably enough. Like one tooth less. Yeah. Smoother. That's good. Really good as well. I will cut this now, but I will, you know, leave a little bit of excess, so I could tension it again, have something to grab. Good. I'm gonna take another break. The last one was about 3 hours ago. Yeah. I will be back in 15 minutes. See you. All right. Let's see. Wish I could see inside there if it is rubbing against it. I don't think so. Yeah. Should be good. Should be good. Okay. Yeah. Now we put the end stops in here. Or yeah, end stops in here, and then we can put it inside. Tall ones. And screws are in 3x10. Okay. For anyone just joining in, we are building a motion control robot. It has pan and tilt and slides back and forth, and also a focus motor for the camera. It is mostly 3D printed. It has custom PCBs, and you can control it via USB and Wi-Fi. Okay. If you have any questions, feel free to send a message. Right. That's that. Now we can assemble the head. Yeah. Let's put this aside for now. Okay. So that's the PCB we sorted earlier. But just, yeah, we are missing some inserts. It's becoming kind of a theme here. Right. Let's see which ones. The normal ones. The other ones are short ones. Okay. Too normal, too short. Hey, Fuzzy, amazing project. I have a question. Is everything powered from the same power supply? Modus Electronics Chemic, do you use separate ones for different components? Thank you. Yes, it is the same power supply. And it's a normal 12 volts power supply you would get for a laptop, or you can just buy them. It has the normal, 5.5 millimeter plug, like the round barrel jack, it's the name. Yeah, and internally there are voltage regulators to strip it down to different voltages. So the 12 volt go directly to the motors or the motor drivers. Then there's a step down to 5 volts, which powers the microcontroller, and a step down to 8.4 volts, which will power the camera. So, and if you have a different camera, you can adjust the voltage. You put a dummy plug or a dummy battery in your camera and plug it in, and everything comes from one cable. The only other thing you have to plug in is USB for data connection. You could also use telnet over Wi-Fi or WebSockets, but I have found them to be unreliable. But the option is still there. But I prefer a wired connection though. Thank you for the question. Good. Now let's hope these were all. All right. We did all of them earlier, and I thought I had them all, but they are sneaky. So this can go. Yes. Did I plan this with standoffs? No. Just screw them on. M2, 6. So chat is getting full again. Welcome everyone. Thanks, quick follow-up, as I'm doing something a bit similar. Nice. For the camera, you're using a voltage regulator rather than buck converter, and it doesn't get too hot even if the camera uses 3 amp at 8.4 volts. Yes. I have found my camera uses 0.6. Good going. Hi. My camera uses 0.6 amps at 8.4 volts. They did not get too hot. Keep it up, love from India. Hey, nice. Thank you. Been to India last year. Really enjoyed it. Yeah, it doesn't get too hot. The ones I have there are rated for 3 amps. So in your case, this would be borderline. But yeah, my camera is also, it says like it takes 3 amps or so, but in practice it's never that high. That's more like a peak kind of thing. What you could do is get a dummy connector and hook it up to a power supply, like a lab supply, and actually measure how much current it draws. And then you can decide which voltage regulator to get. Because there are bigger ones and ones that have a bit more oomph. Yeah. But I didn't need a bigger one for mine. I'm sure must have had chicken curry. Yeah, quite a bit. Chicken and curry. I had... Yeah, we had a good hotel. I had chicken tikka masala. I had butter chicken. I had chicken biryani. The list goes on. There's a lot of chicken. It was really good. Okay, super useful. Thank you for the info. Best of luck with the project. You're welcome, no problem. And also, you know, if you get stuck or anything, write me an email. On my channel there's my email. Just write me an email and we figure it out. It's no problem. Yummylicious. Yep. Miss it a lot, the food. Right, okay. So I'm not completely happy with this mount because all my solder joints are sticking into the plastic. That's not, yeah, that's how it is. That's how it is. Let's get the motors in. Here. Yeah, you asked about buck burst earlier. I have a buck burst converter. It's a tiny little thing. That is the one. Let me see if I can get you clips. This one. On the back side, you have a bunch of solder bridges where you can adjust a fixed voltage. And on the front side, you have a tiny potentiometer where you can adjust a specific voltage. And these ones are rated up to 3 amps, I think, so enough for me. But you can get them in, yeah, like even a little bit bigger, and they go to 5 amps. So I would look on Amazon around, or yeah, maybe even eBay. I had luck on eBay finding these parts. Yeah. Good. I tried some hands-on TMC drivers and Arduino to make a device slider. Didn't go quite well. Fried it up. Oh no. DIY becomes painstakingly punishing at times. So yes. Especially if you put all your time in this and you think it's gonna work, and all it does, it makes magic smoke come out. That's brutal. Yeah. And TMCs are not cheap. That must have sucked, man. Yeah, DIY slider. But TMCs, once you get them running, they are great. They're so quiet. So yeah, amazing. Just amazing. 3x16. We are streaming, yeah, almost 6 hours now. Oh man. But we can do it. All the PCBs are sorted. All the threaded inserts are in, hopefully. I think we can do this. Good. Motor is in. I have to check the orientation of the plugs on the motors so the cabling becomes easier. It's in like this. Maybe a bit wider view is better. Yeah. And we are doing 16. Which to see a completed slider in the morning when I wake up. It's 2 a.m. in the morning. Good wishes. Yeah, you too, man. Just beginning to wonder. It's like 3.5 hours ahead. Yeah. Oh, man. Okay. Have a good night then. Good night. So, motors are in. Good. Great. Yeah, we're gonna do the electronics that go here. We need standoffs. We have M3 standoffs. I'm trying to show you everything, but it's hard. Camera angles and focus and so on. Yeah, maybe like this. Yeah. Sharp enough. Good. Now, this. So, these are the TMC drivers. Our friend here just mentioned he fried one. Yeah, expensive stuff. These are TMC 2209. Yeah, remember it correctly. And the good thing with them is you can just put them in like normal step stick drivers. You don't have to have SPI or UART to configure them. They have 3 configuration flags, and that's all you need. Just with normal DRV drivers or the A4900 or so. Yeah. And for this, that's the ESP focus. And yeah, I think I will be using nylon screws, so I don't short out anything. Well, should I? Nah, I don't like nylon screws. Let's go with M3s. Normal M3s. We get M3x4. Is that the shortest M3 they make, I believe. There they are. Tiny little things. Good. Oh, yeah. You can't see any of them. Oh, let's open it up a bit. That's good. This is right now. Other way around. This okay. Leave the whole dimensions and slightly off on this one. But like 2 screws is all basically. All right. Good enough. Yeah, okay, let's give it a third one. Okay, electronics are in. Get these off. It's there, too short. It's okay. Assembly here. We could get, yeah, let's add the bearing. First bearing. For this we need the base ring. They look the same. No, this is the top. It's the base ring, and then the thing goes on. 5 by 20. These are getting heavy. And then put this one aside. Okay. So we are now adding our first bearing. And we are only almost 6 hours in. Where are 20 millimeters? That's 20. And for the entering. The other ones are 16. Yeah. This is okay. Good. 16. Pull this real tight. Doesn't wobble. Doesn't bevel. It should be. All right. Now let me think about that. Yeah, that's okay. Thinking about my order of operation here. And 70. Nope. Good. You know what? All right. Easier. Perfect. Okay, that's not going anywhere now. That's good. And oh no, I forgot something. Always said. Yeah. I have to put the end stop in before I put the bearing in. Yep. But now we have our good friend, Mr. Drill. Easy. So it's the end stop. Right. This here, the end stop, an optical end stop. Less noise. Here. And 3x8. That's a new one. Yeah. right. This should now just fit in here, right? Yeah. Okay, I will tighten these with a normal screwdriver. Don't want to overstrip them. They are pretty good already. So now let's then put this in. You can see him there. Just did the other one as well. Good, good, good. And now dreimal nach. Good. This sorted is on all crooked. Maybe I just get a different one. Yeah, I can straighten it out. Okay. Good. And stops are on. I think that's as far as I'm gonna assemble it without the cables. Yeah. It's here. Okay, good. Äh, 5 mal 16. 16. Okay. It's now together. I like that. Came out pretty good. Pretty good. Right. So, we're doing with, no, that's, yeah, okay. That's in there, and that's there. Yep, we could add it now. Yeah, okay. Jetzt sind I believe it's the only one up there. Five. That's big ones. This is not all the way in. Yeah, we can fix this from the other side. Good. Good. Okay, coming along. All right. So, no, one is missing. It's like another one of those. Okay. That's good. That is good. Thinking about what to do next. I think I will attach these side brackets here. Okay. If we have a few new viewers in the chat, welcome. Have a seat, grab a drink. So, the other side. Yeah, these brackets are not the best. They are made for furniture, so precision is not that great. But if you No, align them right. They're okay. Good. And for the remaining ones here. Come on. Okay. Last bracket. More. There. Okay. Right. That's good. Thinking about making these brackets black at some point, but yeah, not today. We could assemble the focus pocus. Yeah. And we could, you know what? We could glue the back cover. But yeah, if we want to get it done, okay, maybe save this. Because even though it's late, it's like 11:16 p.m. I want to get this done. Yep. Okay. I have to look for the plans here. Yep. Screen cap. Okay. It's basically here. Like this tiny little axle. Okay. Yeah. Okay. Show you again. Or maybe, yeah, in here. Let's see. That's what we're building. So 2 bearings, 2 washers, and 1 axle. Pretty simple. And washers. Okay, there are the washers. Okay. Just the 2 bearings. Put them in. Yeah, they are not the best bearings. Means they are not exactly 5 millimeters. So this one is good. This one wasn't. Try a few. Or buy better bearings. Oh, crap. This one fits right. This one's okay. This one is okay. So the shitty bearings are okay if you just put a screw through them. They'll use enough for that. But if you have like an axle like this here, then you're gonna have a problem. Right. Or maybe it's the axle. Come on. Both not the best quality wise. Or do they have a slight taper to them? I don't know. Okay, now it's on. So what are the screws? M2x6. Oh, so tiny, these screws. And I don't have them in black. I've just made it now. Okay. So this on, washer on, and you want the big tooth here. No, you don't. Other side. This one here. Big tooth here. Right. Then the second washer on, lid on. Like this. Then put your tiny screws in there. This might be too big. Say 1.5 into 1.3. Good. That's in there. Yeah. Okay. But you know what? I forgot the belt. So same thing back. So that is the belt in there. It's a GT2. What's this feeder? Yeah, it has to have 114. Yeah. little bit. Yeah. What's the washer? Let's do it like this. Put the belt in first. Now it's stuck. Washer on top. Easy peasy. Yeah. Good. Good. It's the belt there. That is engaging. Okay, now we need this tiny NEMA 11, I believe. Oh, it might even be NEMA 7. Ja, lost. Okay. Yeah. These are M2.5 screws, and they attach to these holes in the motor. So what you do, you try to get the belt in there. A little bit difficult. Yeah, got it. The help of a screwdriver. Then you get you clean these holes before you do that. Oh, come on. There we go. Okay, this one is gripping. The other one. Okay, good. There we go. Now we need this little bracket to be able to mount it to a 15mm rod. But there, two of these. Yeah, those. Let's see. Maybe two of those. Goes on like this. So then those screws. What do I need? Five. Let's get it again. For some reason, these require a special key. Like 4.5 or so. Ooh, sorry. Getting tired. No. See, it's not really gripping, but it doesn't really matter. I'll get this going in there. Okay. Good. Focus unit is done. Getting tired. Okay. Let's get the mechanical assembly done. Yeah. Don't think I will be doing the wiring today. That's just too much work. And yeah, I'm already making a lot of mistakes. Let's see. Maybe I continue this tomorrow. Okay. Yeah. That's it. Can't put it there. Good, good, good. In. That's short. Good. Okay. Now this thing. These ones, no. Short. Okay. So just one screw for now. Add the other one later. I want to work now. Okay. Yeah. All right. So I don't believe you want to see me anymore yawning. There we are. Good. I'm gonna wrap it up now. I have been streaming for 6 hours, 46 minutes. Longest stream I've ever done. It's almost midnight here. Yeah, unfortunately I couldn't get the electronics done today. There's too much work. Could need tomorrow. Steady Horse is still here. Oh my god. You must be as tired as I am. All right. Yeah. Yeah, tomorrow's Sunday. Let's do it tomorrow with a fresh mind. Because few of the cables are already prepared. I just have to crimp them and make plugs and sort a bunch of stuff. But I think that's it for today. All right. Thank you everyone for joining. This was amazing. We got quite a lot done. Gonna finish it tomorrow. Let's see tomorrow. I plan for tomorrow, but yeah, let's see how it goes. All right. Thank you everyone and have a good night.